Hello, we're going to look at solving equations in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. X is your independent variable, m is your slope, y is your dependent variable. What you do in x affects y. x1 and y1 are your points. So we have a point of x1, y1 with a slope of m. So for our first example, our point is 1, 6. So this is our x1 and 6 is our x2. The slope was given as 1/2. So we would have the equation y minus, let's get that correctly labeled as y2, y1, y minus y1, or y minus 6, equals negative 1/2. Let's start over again. Y minus 6 equals negative 1/2, our slope, times x minus 1. Okay? And we can leave it in exactly that format. That is the form of the line in point-slope form. Okay? We could do some minor manipulation with distributing the 1/2 and adding the 6, and that would change this into slope-intercept form. Okay, I'll give you a few seconds to think about that. Pause the video if you need to. Moving on, let's look at doing finding an equation in point-slope form from a graph from 2 points. So we've got the point -2, 6 and the point 4, 6. Our slope we find with point y2 minus y1, the rise, divided by x2 minus x1, the run. And our points, and it does not matter which one we call point 1 and which one we call point 2. So I'm going to call this x1, y1. I'll call this one x2, y2. It is very helpful to make certain you label. Okay, so now y2 would be 6 minus -6. x2 is 4. x1 is -2, so that would be 4 minus -2. This would reduce to 12 plus 6, so m equals 2, and I'm sorry, I should have said this would be 6 minus a -6. 6 plus 6 is 12. 4 minus a -2 is 4 plus 2, or 6. 12 divided by 6 is 2. We've now got our slope. So it does not matter which of these 2 points I use. They will both reduce exactly the same way. So the equation would be y minus, let's go ahead and use this first point, y minus 6 equals 2 times x minus 4. And here we are going to change this into slope-intercept form. So y minus 6 equals 2x minus 8. Adding 6 to both sides, we have our equation of y equals 2x minus 2. Had I used the other point, and I think we need to see this, okay, it would have been y minus -6, put the parenthesis in the correct place, minus -6, let's get that cleaned up so that it's real clear what we're talking about, equals 2 times x minus -2. So this becomes y plus 6 equals 2x, and this would be x plus 2. 2x plus 4, if I subtract 6 on both sides, y equals 2x minus 2. And you can see that these two equations are identical. Give you a moment to process that. And we're going to move on. Okay, writing an equation from a function. Well, a function is f of x equals y. That's the definition of a function. So this is 0.8, -1. The function of 8 equals -1, or f of x equals y. And so then we've got a second point of 6, 0, f of x equals y. And I've got 2 points again, so I'm going to find my slope. M equals x1, y1, x2, y2. I'm going to go 0 minus -1, 6 minus 8. So I'm going to get 1 over -2, or my slope equals -1/2. And it did not matter which order I put this in. Okay, so now I'm going to choose a point. This point, frankly, looks like it might be slightly easier to manipulate. So y minus 0, using this point, equals -1/2 times x minus 6. And let's go ahead and clean this up a little bit. So y equals -1/2 times x minus 6, or y equals -1/2 x plus 3. I could have substituted into the other equation also. Let's move this so it's not at the bottom of the screen. Sorry, folks. I could have said y minus -1 equals -1/2 times x minus 8, using this point. So y plus 1 equals -1/2 x plus 4. Subtracting 1 on both sides, y equals -1/2 x plus 3. I'll give you a second to process that. Okay, we're going to look at how this would work with a different kind of equation here. So we've got Best in Town Taxi charges a start fee and a mileage fee. The table shows the total cost for the different distances. Can this situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of miles. The distances. For 4 miles, you paid $18. This is your x value. It is your independent variable. These are your y values. They are dependent. The cost depends on the number of miles. It costs $23 to go 8 miles. $10 to go, 10 miles cost $28. $33 for 12 miles. And the first thing we need to do is we need to check our slopes. So m equals, and I'm just going to choose these 2 points, 23 minus 18 divided by 8 minus 4. So this would become 5/4. Let's check this point. And this, we're just checking for a constant slope to make certain our rate of change is constant. 28 minus 23. This is my y value, and I'm subtracting my x value, keeping them in the same order. I would have 10 minus 8, and now I've got 5/2, so not a constant slope, not a constant rate of change. Okay, we're going to go ahead and take a few minutes for that, not a constant rate of change. And I'm going to pause for a moment. Okay, we've now got Town Taxi, who uses this table to calculate its fees. Can it be written as a linear model? So we're going to be working on its slopes. So we're going to find m, and we're going to look at, and you see the table is slightly different. They're charging $13 for 4 miles distance instead of $18. So the y values are 23 minus 13 divided by 8 minus 4, the x values. So I have 10/4. This reduces to 5/2. Coming down here, m equals 28 minus 23 divided by 10 minus 8, which is 5/2. That's looking promising. And our final value, the costs are $33 minus $28. Those are our y values. And 12 minus 10, that is also 5/2. So we can now choose any of these points to write our equation. So y minus, let's just choose this first one, 13 equals 5/2 times x minus 4. This would be an ideal candidate for writing in point-slope form. So y minus 13 equals 5/2 x minus 10. 5 times 4 is 20, divided by 2 is 10. I'm going to add 13 to both sides. Y equals 5/2 x plus 3. Now, we're going to do a little bit of corroborating here. Does this work for point 823? So if I say 23 and I'm questioning, does that equal 5/2 times 8 plus 3? So this would be 40 divided by 2. So 20 plus 3. We can see that this is a good point, so we've got a good equation. Let's try it for point 1028. So does 28 equal 5/2 times 10 plus 3? Well, this would be 25 plus 3. This is a good point. And our final point would then be point 1233. So I'm feeling pretty confident about my equation right now. Substituting 33 for my y value, does that really equal 5/2 times 12 plus 3? Well, 12 divided by 2 is 6, times 5 is 30. 30 plus 3 is 33. So we've got a valid equation that incorporates every one of our x values. Thank you.